What is ultraviolet catastrophe and how it relates to bridge between classical mechanics and quantum mechanics, and how Planck's equation, that is E is equal to h mu, becomes a foundation of quantum mechanics. We know Blackbody radiate energy. The Blackbody radiate energy of different possible frequency, and the relation between energy density and frequency is governed by energy distribution law. And the dependence of energy density and frequency is governed by this straight line graph. When the frequency is less, the energy density less. With increasing frequency, the energy density increases, but after a certain value, with increasing frequency, the energy density decreases. And to relate mathematically the relation between energy density and frequency, different experimental formula comes into play. First is the Rayleigh-Jeans experimental formula. Rayleigh-Jeans experimental formula says that the relation between energy density and frequency is direct. That is, the energy density is directly proportional to the square of frequency. But see, when the frequency is low, the energy density must low. But when the frequency become high, then the energy density must tends to high. But the graph shows that with increasing frequency, the energy density must decreases. But the formula says it must increases. This is what ultraviolet catastrophe says. The ultraviolet catastrophe says that with increasing frequency, the energy of black body must increases to infinity. But the total energy of black body remains constant because it depends on temperature. And with increasing frequency, the graph says that the energy density must decreases, but it could not explain by Rayleigh-Jeans law. So Wens came up with idea. In Wens formula, there is extra term, and that is Boltzmann factor term, which leads to decrease in energy density with increase in frequency. Here, when there is increase in frequency, the Boltzmann factor term allows us to explain there is decrease in frequency. But the Wens formula could not explain correctly the frequency dependence of energy density at a lower frequency. It only explained the relation between frequency and energy density at higher frequency. And the Rayleigh-Jeans formula only explained the relation between frequency and energy density at a lower frequency. So, to solve this, Planck came up with his idea that the energy is no longer continuous. Here, the Rayleigh-Jeans experimental formula and Wens experimental formula completely based on idea that energy of the radiation is continuous. But Planck described the assumption. He take the assumption that energy of the radiation is no longer continuous. It is discrete. The discrete nature of radiation is due to the wave nature, and the energy of the wave is equal to h mu. When Planck came with the idea that energy is discrete, it shows that the energy of the radiation comes in form of packet, and the packet of energy is known as photon. And the energy density is not only depends on energy of photon, it also depends on number of photon. Let's see. Here use the energy density. Energy density is equal to energy divided by volume. And the total energy is equal to n. N is equal to number of photon. N times h mu by b, where n by b is equal to number of photon or photon density times the average energy. So the energy density not only depends on average energy, it also depends on number of photon density. So with this idea, Planck's mathematically derived formula between energy density and frequency, and that is U mu is equal to 8 pi h mu q by cq 1 by e to the power h mu by kBt minus 1. In this formula, at lower frequency, that is h nu by kBt less than 1, leads to Rayleigh-Jeans formula, and at higher frequency, that is h mu by kBt greater than 1, it leads to Wens formula. But how it explains the catastrophe? Let's see. When The when the frequency become low, the packet of energy must low, and with increase in frequency, the number of photon, that is the number of packet also increases. That's why energy density increases. But with increase in frequency after a certain value, then the energy density decreases. The energy density here decreases does not mean that the energy of photon decreases. The energy of photon still remains increases. That is E is equal to h mu. When frequency increases, the energy of photon also increases. But we have the total energy is equal to constant. When is equal to constant, then the energy came up with packet with higher frequency. The packet of energy, that is photon, is high, but the number of photon, that is the number of packet, is low. That's why the energy density become low. So with increase in frequency, the energy of the photon increases, but the number of photon density decreases. As the number of photon density decreases, the energy density decreases. That's how the ultraviolet catastrophe, that is when energy density increases with increase in frequency, is explained by help of Planck's assumption. And this assumption of discrete nature of light or radiation leads to a foundation of quantum mechanics. Okay.